So hello guys, welcome. Today we are going to start XML with session 1. So today we'll discuss the topics: the markup language, the benefits of XML, how to format XML document, what is a parser, and building a complete XML document, a well-formed complete XML document which may require a character data, processing instructions, entities, the doc type declaration, attributes, and so on. So now we start with the markup language. What is a markup language? A markup language defines the rules that helps to add a meaning to the content and a structure the document. So they are classified as stylistic markup. It depends the presentation of the document. Structure markup, which defines the structure of the document, and semantic markup, which defines the content of the markup. So based on this, we have different types of markup languages. GML, that is generalized markup language, designed in 1970, which describes the document in terms of its format, structure, and other properties. SGML, that is standard generalized markup language, designed in 1980, which ensures that the system can present the data in its own way. HTML, hypertext markup language, designed in 1989, used ASCII text, which allows the user to use any text editor. Next markup language is the XML that we are going to talk about. It stands for extensible markup language. XML tags are not predefined. You must define your own tags. Unlike HTML, the tags will be defined by the user. It's a self-declaration tag, self-descriptive tag. You need to define your tags by own. XML is a set of rules for defining semantic tags that break a document into parts and identify the different parts of the document. XML uses the DTD, that is a document type definition, or an XML schema to describe the data. It inherits the feature of SGML and combines it with the feature of HTML. So XML has developed over HTML because of the basic differences between them given in the table below. So the HTML was designed to display the data, whereas XML is designed to carry the data. HTML displays the data and focuses on how the data looks, but XML describes the data and focuses on what the data is. HTML displays information, whereas XML describes that information. So what is the conclusion? If you want to present the data, go for HTML, but if you want to store the data, carry the data, you go for XML. Now let's see the benefits of XML. There are some benefits of the XML. So the first is the simplicity. The information coded in XML is easy to read and understand, plus it's processed easily by computers. Openness. XML is a W3C standard endorsed by the software industry. Next benefit is extensibility. There is no fixed set of tags. New tags can be created as they are needed. Next benefit is self-description. XML documents can be stored without schema because they contain metadata. Any XML tag can process an unlimited number of attributes such as the number, version, and so on, the author. Next benefit, it contains machine readable context information. The tags, attributes, elements, structures, provides context information, opening up now and probability of higher efficient search engines, intelligent data mining, agents, etc. The next benefit is separates the content from presentation. XML tags describe meaning, not presentation. So the look and feel of an XML document cannot be controlled by XSL document to be changed without touching the content of the document. Multiple views or presentations of the same content are easily rendered. The next benefit is supports multilingual documents and Unicode. It is important for the internationalization of application. Next benefit is can embed multiple data types. XML document can contain any possible data types like multimedia data, image, sound, video to active components. There are many benefits of an XML. Now, what is the code difference? Let's see the example of an HTML versus XML code. The HTML code, the tags are predefined. You can see the tags UL, another list, li tag. The tags are already predefined. But in case of XML, it's a user who is going to define the tag depending on the data. So I need to store the details of an employee. So I'm storing under the details root tag. Within the details you can see contact, then the person name close, ID information, ID close, company information, company close. So that is an example of an XML code. Let's show you an example. Let's say for example let's say we have a document that is, let's say the IT school is a root element which contains semester 1, semester 2, semester 3 as a child, and the semester 1 has its child subject 1, subject 2, subject 3. If you subject 1 contains some information, subject 2, subject 3. So if you want, let's say if you want to add semester 4, you can add semester 4 start, and then let's say semester 4 close. Within semester 4 you can have, let's say again, the subjects. So you can just put some subjects in semester 1. Semester 4, let's say semester 4 subject is you are teaching as, let's say MySQL. Then let's say you are teaching SQL Server, and let's say you are teaching an Android. So that is how you can add. If you want to add subject 4, you can add a subject 4, but make sure it should be properly aligned, properly formatted. So let's save and run this document. Now you can see the document IT school semester 1, this block. So you can see it's a tree shape, it's a hierarchical order. IT school contains semester 1, 2, 3, 4. Semester 3 this books, semester 2 these subjects, semester 1 these subjects. So it presents on the displaying the data, carrying the data, not the presentation. Now coming to the parser. What is a parser? A parser helps the computer to interpret an XML. Whatever the file you have, it will be interpreted, it will be parsed by the parser, and it will be viewed. So you design your XML document, the parser will parse and it will be viewed. So there are two different types of parsers. So the non-validator parser is that does not validate the document. whereas the validating parser is the which validate the document, which needs a validation that depends on the whether they check the XML document for validity or not. It depends on that. Just for example, the few non-validating parsers are OpenXML in the Java, Lark, that's an parser in Java, then XP, that is also used in Java. In the C we use expat. Few validating parsers are XML4C, then XML4J, that is IBM used in Java. Then next is MSXML, that is used for Microsoft. So these are the few parsers that is being used. Now the parser, as if you know, it parses the document, it interprets the document. Let's say it parses the load the XML and other related files to check whether the XML document is well formed and valid or not. XML document structure. An XML document is composed of set of entities defined by unique names. All documents begin with a root or a document entity. Entity means an entity, that are alias for a complex functions. You can use an alias, you can use the short term for any description. Documents are logically composed of declarations, elements, comments, character references, and processing instructions. A well-formed and a well-documents. So let's see how to form a well-formed XML document. An XML document is considered as well-formed if a minimum set of requirement defined in the XML 1.0 specifications is satisfied. The requirement ensure that correct language terms are used in the right manner. A valid XML document is well-formed XML document which conforms the rule of DTD, that is document type definitions. The DTD defines the rules that an XML markup in the XML document must follow. So data versus markup. Data is the Tom Cruise, whereas the markup is the name. The name tag, that is a markup, and data is Tom Cruise. So how to create a well-formed XML document? The first step is state an XML declaration. You declare your DTD, create your root element, create your XML code, and verify. So the syntax that we should use: XML version 1.0, standalone, no or yes. Standalone and encoding are optional, but this version is the mandatory. So standalone, if it is no, that means whether you are using an XML document or not. So standalone, no, so it's not an standalone, it needs an XML external file. That means your DTD file should be external. But suppose your DTD is in the same file, you need to write down standalone yes. It's the standalone, it does not have any external file. Encoding UTF, it's not P, it's UTF-8. Then XML 1.0 is by default its version. Creating a root element, there is only one root element, that is for here is book, which describes the functions. Creating the XML code, it is the process of creating our own elements and attributes as required by our application. Elements are the basic unit of XML document. Tags tell the user agent to do something to the enclose in case. So let's say the opening tag and the closing tag, and this is the content. The rules that will follow while creating an XML code. At least one element required. XML tags are case sensitive. It's not like HTML. HTML is not case sensitive, but XML tags are case sensitive. Ends the tag correctly. Nest the tags properly. It should be properly nested. Use a legal tags. length of the markup names, define a valid attributes. The final last step is verification of the document. Verify the document, otherwise it will not be read by the browser or any XML reader. The comment, this is an information how for the understanding of the user and is to be ignored by the processor. So for the comment you can just use the angular brackets, exclamation, double hyphen, and you write your comment and close with double hyphen and angular bracket. Now processing instructions, a processing information is a bit of information meant for the application using an XML document. These instructions are directly passed to the application using the parser. So question mark XML, the style sheet type and text slash XSL. So in case you need, this is the type of application and the instructions information if we are passing to any other applications in that case. Now the data can be a character or a different. The text between the start and end tag is defined between the character data. The character data may be legal Unicode. The character data is defined into two types, the PC data and the C data. So the PC data means a parsed character data. Parsed character data is the text that will be passed by the parser. It needs a parsing. The tags inside the text will be treated as a markup, will be passed if we are using ampersand GLT, that is a less than, ampersand GT, that is a greater than, ampersand AMP, that is ampersand, ampersand quote, that is a quotation. C data, that means it's a characterized data. It will not be parsed by the parser. The C data are used to make it convenient to include a large block of special characters. The character string is not allowed within a C data block, as it will be signal to end of the data block. So the entities, next to the entities are used to avoid typing long pieces of text repeatedly. If you want to type some information repeatedly, you just use an entity, you use an alias for that. So the syntax is, let's say, address. So whenever I'll use the address, it will show me this piece of code. That is a general entity. If you want to use parameterized entity, you can use percentage and so on. The types of entity is parameterized and general entity. So if it is parameterized, you can use client is equal to ampersand uptick, the product is equal to product ID, and so on. That is an example where you should use, but the declaration should be hashtag parameter underscore entity name, and the example is the, let's say, percentage address. Entity full address, whenever you use full address, it is such like that. So I'll demonstrate an example. Let's see how we should declare a doc type. So the first is you declare an XML version, standalone, and encoding is optional. Then your doc type, your declaration, all the entities, all the elements, PC data or C data. The attributes, you can also define an attributes. Attributes means, for example, let's say TV, the count, this is an attribute. The attributes gives an information about an element. The attributes are embedded in the element start tag. Let's demonstrate an example. Let me show you an example that will show you. Let's say this is an example. So the first is XML version. I told you encoding is optional, standalone is optional, but even though you can write, that is your choice. Now we'll start with this is an DTD, document type definition. So let me define my document. The doc type, it is student. So student is the root element. Student is the root element. Then element student, the root element should contain the fourth child in this sequence. So now let me clear you. The sequence defined here does not matter. It matters how I have defined here. So the sequence should follow: the first child element should be profile, the next child element should be identity, next child element should be surname, and last child entity should be first name. It should follow this sequence inside the root element student. So the element identity should be PC data, it should be parsed data, parse character data. Element profile should be empty. Then next is the surname. It's again the PC data, sorry, first name, PC data, surname, PC data. You have seen here the sequence is different. It does not matter. So while defining this, the sequence should follow this one. Now coming to the attribute, I told you attribute. So for attribute for the profile, I want to use an image. So I have used profile image is an entity. For the profile will contain an image. So profile tag will contain an image attribute. So if I use the profile, it should contain an image attribute, and that image attribute should be entity, and it is required. You can use hash required if you want to make it required, or hash implied in case you don't want required. Now for this entity A, I use the entity name A. Instead of typing this long code here is equal to this, I want, instead of typing this long code, I can just type A. So entity A system, I have just used this. So instead of writing this whole line, instead of writing this whole URL here, I have just used A. So I can use A is my entity. That's an alias. Next, the attribute list is for identity. For the identity, I have used the attribute list, that is STID. So my identity is student ID, so I used STID. What is it? It's an ID. It is an ID because it's an PC data, so you should define it's an ID, and it is also required. So now following this, now this is a DTD, so I must follow this. It's must, I must follow this, so my document should be verified. So student is the root element, so I used student. Profile is my first child element, profile. It should contain an attribute called image, I used attribute image. A, which is an entity. Then next is identity, the next should be identity, I used an identity. It should contain an attribute called STID, I used STID, that is an ID. Then next surname, next should be surname Smith, first name Joe. So if I run this document, I can see this is how what shows me if I run this document. Profile image A, student identity, surname, and the Smith, surname Smith and first name Joe. So that is what that is an example for using an attribute, an element, identity, and showing when I showed you the example of entity and attribute list. So that is what in the session 1. You can see session 2 in upcoming days. In case of any questions, you can write down in a comment, and I have already shared you these examples in the description. You have given, there is a link. Thank you.